Bismillahirrahmanirrahim. Assalamu alaikum viewers. Today I will show you how to solve question number 16 of exercise 2.3. Before starting the question, I will let you know that you often see this question in the up-to-date papers of Lahore board and many other boards. So let's start the question. First, I simply write the given expression as it is and make a simple change. As you can see, I just remove the radical symbol and change it into the form of power 1 by 2. The negative sign as it is, the 1 as it is, the same process is here. I remove the radical symbol and change it in the form of power 1 by 2. So we know that when a term is positive, having positive power in the denominator, when we shift it in the numerator, its power becomes negative, as it is a rule. So I write here differentiate with respect to x on both sides, and after writing this sentence I apply operator d by dx on both sides of this equation. Now this d by dx when multiply x to the power 1 over 2 is written as it is, the negative sign as it is, and this d by dx apply onto the second function. So we have to see here power 1 by 2 and here negative 1 over 2. So we apply power rule. The power rule is we write power 1 by 2 first and the function as it is x to the power 1 over 2 and decrease 1 from the power into extra derivative of the function without any power. So it become d by dx of x, the negative sign as it is. This negative power I write in the start because I apply here power rule. The power rule is whole powers is written in the start and x to the power negative 1 over 2 as it is and decrease 1 from this function in the power into extra d by dx of function without any power. So 1 over 2 as it is, half minus 1 is negative half, and this d by dx of x, or we can say when we take derivative of x with respect to x, its answer is 1 and I don't need to write here 1. I just simply ignore these terms. This negative become positive, this half as it is, and this negative half and negative 1 becomes negative 3 over 2. And similarly, as I discuss here, when we take derivative of function x with respect to x, its answer is 1 and I don't need to write here 1. Okay, the question is moving on. As we know that when a term having negative power in the numerator, when we shift in the denominator, its power become positive. The plus sign as it is, the power is negative in the numerator, it become positive in the denominator. And the next step I write x raised power 3 by 2 as x times the square root of x, because we write x to the power 3 over 2 into x to the power 1 and x to the power 1 over 2, and when we add 1 plus 1 over 2 it gives us answer 3 over 2 because the bases are same and the powers are added. This x as it is, this power 1 by 2 is written as a symbol of square. Now move on. This d by dx as it is, as we see here two fractions with different denominator and a plus sign, so we our next step is to take the LCM. So I have to make the denominator of both fractions same. In the left expression, x is missing. If I put an x in the left fraction, then I will get the same expression written on the right fraction. So I will just write x in the numerator and x in the denominator to make the denominator of both two above functions same. Now denominator is same, I put a bar and write the denominator to x the square root of x, and the function of numerator is as it is, 1 times x plus 1 as it is. This is the derivative of the function. I write in the start of my question. Okay, but our target is that we have to show that 2x into dy over dx plus y is equal to 2 square root of x. Now move on. I have to show this. So I take left hand side of this expression. Uh, I simply write the left hand side. As we can see in the left hand side expression, there is a function dy over dx. We find its value in the upper case dy over dx. We put its value dy by dx is equal to x plus 1 over 2x into square root of x. I just simply replace this d by dx with its value and this y. In the start of the question, this is our question. So I replace this y with the square root of x negative 1 over square root of x. In the left fraction, this 2x and this 2x both same and multiplying, so they will cancel each other. Now the next step will become this x plus 1 over square root of x, this x plus 1 over square root of x plus the square root of x negative 1 over square root of x. So we have three fractions here and I put the middle number, I put a 1 in the middle number of the, so it become a fraction. Now the first and the third fractions both have denominator square root of x and the middle is missing, so I write simply square root of x in the denominator and in the numerator, so we have same denominator for these three fractions. Now our LCM is so easy. I just this square root of x is written three times. I write a bar and write it only one time, and the numerator function is written as it is, this x plus 1 as it is. This square root of x times square root of x becomes x, and this negative x as it is. This x and this x becomes 2x, and the positive and the negative one will cancel each other. And we know that x over square root of x can be written into square root of x, and this is the justification for this step. So I write square root of x in the place of x over square root of x. So this is our required right hand side, and hence it is proved. Our question is end here. If you like, then share and subscribe with your friends and family members.